Okay, so you already know me a bit, and the second topic I will be talking today is NDS.Live over AUTOSAR. So Fabian made a short introduction to it. And first of all, I would like to mention why we as Intellias are contributing to this activity. We are an associate AUTOSAR partner since March 2022, and we are contributing to a few topics within AUTOSAR community, like extending the manifest for safe hardware accelerators in adaptive platform, integrating Rust programming language into adaptive platform as well, and some development and maintenance of the adaptive platform demonstrator. At NDS, we started our way just a year ago and not contributing that much yet. So just attending PDG and doing some marketing activities. And this POC is aimed to join these two worlds of NDS and AUTOSAR, and to be more specific, NDS.Live and adaptive AUTOSAR platform. Yeah, we are first of all very grateful to NDS organization to for this possibility to contribute, because we can share our expertise in both topic and contribute to this both standards. So there was a task force activity established and led by Fabian. By the way, Fabian, thanks a lot for your support and the patience, because it was tough sometimes. The main idea was to develop some reference implementation of NDS in AUTOSAR and to transfer NDS data over some IP protocol that is used internally in the AUTOSAR ecosystem. You might remember the picture on the left. It was demonstrated by Fabian 2 years ago. I guess it was the first iteration of this POC, and there the NDS.Live data was transferred over some IP protocol, but between some mocked applications emitting speed limits and consuming speed limits. In our POC, we are making a step towards integration with the AUTOSAR adaptive platform, and we are developing AUTOSAR applications, the publisher and the subscriber that will connect to the NDS Smart Service, grab the speed limit data, and then push it into in-vehicle communication channels. The idea was to work with the speed limits because, of course, due to ISA and CAP regulations, it's an important topic right now. The motivation why we are integrating with adaptive platform and why with AUTOSAR. So first of all, we are on the conference dedicated to the standard. So everyone knows all the benefits that standardization offers, and NDS and AUTOSAR are leading standards in their niches. So this integration can offer seamless operation across various vendors and platforms. It also aims to enhance functional safety by utilizing real-time map updates and continuously inform in-vehicle applications on the map data changes. So service-oriented architecture is at the heart of AUTOSAR. And NDS.Live also embraces this approach. So that was also the good point for the integration. And adaptive AUTOSAR, it supports high bandwidth connectivity, which is actually crucial in our case because we need to transfer map data. Also, it offers high performance capabilities for computing and making this platform perfect for integration with NDS.Live frequently updated services. And both these standards, they have a modular approach, allowing the selective updates and optimizing system performance. I'm referring a lot to adaptive AUTOSAR, so maybe a quick overview what is AUTOSAR and what is classic and adaptive. So AUTOSAR is a worldwide partnership established by leading car manufacturers and suppliers with the goal to create a unified software infrastructure for autonomous systems. for automotive systems, sorry. And classic AUTOSAR was designed to support static, hard real-time events. But as technology progressed, the need in the more dynamic platform arose, especially to cater the needs of autonomous driving, of enhanced connectivity features, and adaptive platform was introduced. So this platform, it has advanced computational and communication infrastructure, which makes possible integration with external services, because actually establishing connectivity between classic AUTOSAR and NDS.Live service in the cloud was barely achievable. This slide shows the AUTOSAR architecture. I will not go into details, but what is important to understand our POC is the AUTOSAR runtime for adaptive applications. So this is the runtime environment that supports adaptive applications and makes sure that their life cycle and they have all the necessary hardware resources to function. And the application layer itself, where all the business logic sits. So our applications were developed in application layer, and they are running in the AUTOSAR runtime, which is called ARA shortly. Also, AUTOSAR organization, it provides all the partners with the adaptive platform demonstrator. So you can think of it like a combination of software example, runtime environment, and development support to develop AUTOSAR applications. And we were using APD, of course, for our POC, and it can be installed either on the real hardware, like the Raspberry Pi, or on some virtual hardware like QEMU. The most important slide of the presentation, our POC architecture. So we can start from the left. So on the left, we have Smart Layer Pass Horizon service generously offered by our NNG colleagues. The decision was used to work with the Pass Horizon service because for the speed limits, it doesn't make much sense to have all the tile information. So it's enough to know the speed limits on the car traversal. And despite the adaptive platform has a high bandwidth connectivity, it still encourages to minimize the data amount that are transferred via internal AUTOSAR protocols. Then we have our APD environment. So we used virtualized QEMU hardware and Linux operating system installed. Adaptive Platform Demonstrator, it provides reference implementation for APIs and services. And we are mostly interested into ARACOM, which is a communication management API. It allows to build both event-driven application or polling ones. And in our case, we are interested in event-based approach. So we had to implement two applications. One is publisher, NDS.Live publisher application, and one is NDS.Live subscriber application. APD also defines some important aspects like a proxy skeleton architectural pattern that we also had to use in our implementation. Now to the logic. So what happens? Publisher application is responsible for communication with the NDS.Live smart service and responsible to pack and to send the coordinates, the vehicle position. So that's why we need there the C++ bindings and zero runtime. So it packs car position and sends it to the Smart Layer Pass Horizon service. Then it receives the NDS data, packs it into the data structure for the events, and pushes this event to the internal communication channels of ARA, so adaptive runtime. And then the subscribers, we can have several subscribers, they receive this data and they are responsible to deserialize this data. So the data is transferred within AUTOSAR environment in blobs, in zero blobs without any deserialization, and deserialization happens on the subscriber side. This decision was made because it allows to save some computational resources, and also like subscribers, they can just parse the header and check if there is a needed data, needed layers for them. So basically, in a nutshell, so we have smart layer service. The publisher application makes a call, gets the data, pushes it into the communication channels over some IP protocol, and the subscribers receiving the data and deserializing to get speed limits in our case. And short video. So in this video, this is the adaptive platform demonstrator environment. There is no fancy UI, just logs. And publisher and subscriber are running simultaneously, but here we are just grabbing information from the logs, and the video is paused intentionally to have some time to check what's in the logs. Let's see. So first checking the logs of a publisher application. And we see that it received the binary data from the NDS smart service. And now checking the logs for the subscriber application. Here we see that it parsed speed limits. So there are a few different speed limits received. So first one is 40 kilometers per hour. Next one is 25. So we have done it intentionally for demonstration. And one more. Again, 40 kilometers per hour. So subscriber application, it received 3 speed limits and parsed the serial blobs into kilometers per hour. Yeah. Okay. During this implementation, we faced several challenges. As both standards are pretty new and still actively evolving, there was no like ready recipes or best practices to follow for the solution. And of course, embedded platforms, they possess a lot of restriction on external communication for security reasons. So there is no AUTOSAR spec available to connect to the internet or cloud. Another challenge that we faced was a reconstruction of the NDS binary data into the data types within AUTOSAR environment, because the C++ reference implementation was not that easily integrated into APD environment. And APIs that are exposed by AUTOSAR, they are missing for the moment some crucial software components like SSL support, for example, but we raised several requests to AUTOSAR to do this integration, and there is a ticket number for the internal system. Some ideas how to evolve this POC. So first of all, we can enhance it to onboard some new use cases, not only for speed limits. There is a lot of other information in the maps. Second step is the ZSWAC library integration. We tried to do it, but faced the C++ versions incompatibility. Fabian can elaborate more on that. The third one is integration with the adaptive platform to gain the native support, as we requested already for communication. Of course, the cybersecurity topics, we might collaborate with AUTOSAR community to add some encryption for the NDS data to make it more secure. Addressing also the fault tolerance topic. So for the speed limits, we can have some fallback scenarios like going to the region-wide speed limits or adding some confidence indicator to the value to make sure that the values received are reliable enough. And the last, most interesting for us is the integration to Intellias Automotive Portable Kit. On the next slide, I will show what is this. So this is a portable kit that we built for demonstration purposes to demonstrate like Intellias expertise in different areas. These are like two boxes. So one box is a portable ECU that has the classic AUTOSAR installed there currently, but we are working to get another guest OS for the adaptive platform. And the second one is actually based on the Qualcomm, and it has instrument cluster and IVI and ADAS screen, and we can like emulate different signals, car signals, and show different scenarios on the cluster, like in the car. So the idea is to get speed limits from the cloud, processes via the adaptive AUTOSAR installed in the portable kit, and show the speed limits on the cluster. That is all from my side. I hope I'm in time. Yeah, good.
Yes, you are. Thank you
Great.
very much. So please stay here for one question here we got in the forum. The AUTOSAR stack, like ETH, is not used to get the NDS data, right? That's the question. Is the AUTOSAR stack used to get NDS data?
So this is what we did in this POC, like trying to get AUTOSAR stack to work with the NDS data. Yeah.
Questions in the audience? Yeah, we have one.
Yes, first of all, thank you very much for both of the talks. I appreciate it a lot that you're getting very technical. And yeah, at one point, I just have a question, maybe I misunderstood you. You were explaining how the data is being delivered from the Horizon to the ARA backend. And then you said all subscribers are not notified. So it seemed to me like a broadcast message.
Yes. So, but this broadcast happens within AUTOSAR runtime environment. So adaptive AUTOSAR, this publisher application, it broadcasts the message over some IP, and then the subscribers, they're getting this data.
Okay, but you're not concerned about like exponential network traffic growth if you do like the broadcast?
A good concern, but we will have to take it with our AUTOSAR experts, I guess. Yeah. But here we were sticking to the speed limits, so that's not a big amount of data. Yeah.
Okay, just because I wonder, because usually you have like a sharding algorithm, and people who are too far away, they don't need to get notified about some information elsewhere. So in car.
In car, yeah. So this is not this all happens in car. Yes.
I thought it's being delivered by the server.
Yeah. So the publisher application is already within the car. So
okay, then it makes sense.
Yeah,
all right.
yeah. So it's all within
Thanks
the
for clarifying.
car. Yeah,
all right.
Yeah. Thank you.
Okay. No more questions online. No questions here. And thanks again.
Thank you. Thanks again.